To discuss some problems on binomial distribution. So let us start with a problem. Let us start with a problem. N irregular six-faced dice is such that the probability that it gives three even numbers in five throws is twice the probability that it gives two even number in five throws. How many sets of exactly five trials can be expected to give no even numbers out of 2500 trials sets. So now here we will throw a dice which is irregular. That means probability of the success one event we cannot say 1 by 6. It may be anything between 0 to 1. And here my random variable will be nothing but the happening of an even number in five throws. So we can have the probability statement for this. So if we find the probability in one set, then we can multiply it by 2500 set. So in order to find the probability in one set, what we will do, let us consider, let x be the random variable, x be the random variable of getting even numbers. And so according to the question, what will happen? Probability of getting three even number is equal to twice the probability of getting two even numbers. Using this one, we can find small p and q. Then our job will be over. Now, what are the things given? Here we are having number of trials are 5. So small n is nothing but 5. And here we know 3 or 2 are the R. So what we will do here is we will apply binomial distribution and we will try to find P. If we find P, then we can able to find q because p plus q equal to 1. So n equal to 5. So what is the thing? What is the meaning of in case of binomial distribution? What is the probability x equal to r? Probability of x equal to r is NCR p to the power r into q to the power n minus r. But here somewhere r equal to 3, somewhere r equal to 2. So we can equate both sides. So in this left side, what will happen? 5c3 p to the power 3 q to the power 5 minus 3 is equal to twice 5c2 p to the power 2 q to the power 5 minus 2 5 minus 2. And if you simplify this, 532 is equivalent to 523, 5c3 is equal to 5c2. And so here PQ is there, P square is there. So if I cancel both sides, it will be P. Here I will have Q square, here I will have QQ. So if I cancel, I will have Q. And so we know P Q equal to 1 minus P. So P equal to 2 into 1 minus P. And from here we can get P equal to 2 by 3. P equal to 2 by 3. If P equal to Q 2 by 3, Q will be nothing but 1 minus P, and that is equal to 1 minus 2 by 3, and which is equal to 1 by 3. So this is the value of Q. This is the value of Q. Now what we will do, we will try to find probability of getting no even number. Here because we have to find probability of getting no even number uh, in 2500 sets. How many sets of exactly 5 trials can be expected? So we have to find number of sets where there will be no even number. So first we will find the probability of not having an outcome is not an even number. So probability of no even number means it will be x equal to 0. And so that equal to 5c0 p to the power 0 q to the power 5. And 5c0 is 1, p0 is 1, and that will be nothing but 1 by 3 to the power 5. And if you simplify, you will get 2, 4, 3. Now this is the case of no even number one set. Therefore, number of set, number of, therefore, number of sets having no even numbers in the set of 2500 is equal to 2500 into probability of x equal to 0, and that will be equal to 2500 into 1 by 243, and that will be approximately 10. So there are 10 sets where we will have no even numbers, then we will take another example here. Example, two dice are thrown. Two dice are thrown 120 times. Find the average. Find the average number of times in which the number on the number of the first dice, the number of the first dice, first die exceeds the number in the second die. So what does it mean is we are throwing two dice 120 times, and now we will find average number of times in which average means mean. We will find average number of times in which the number in the first dice exceeds the number in the second dice. So here what I will do, you see, if we throw two dice at a time, we can have 36 possibilities. So two dice if we throw, if two dice are thrown, then the total number of outcomes, total number of outcomes is nothing but 6 to the power 2. That will be 36. Now, out of these 36 outcomes, I am interested of the outcomes where the number in the first dice exceed the number in the second dice. So let x be the random variable where the number in first die exceeds the number in second die. So number in first die exceeds number in second die. That means what will be my x? My x will be 2, 1, 3, 1, 3, 2, and so on. So I will have 6, 5. So total I will have 15 such favorable outcomes. 15 such favorable outcomes. So that means now if I find probability of success means getting the outcome where the first dice is more than the outcome in first dice is more than the outcome in the second dice. So we have total favorable cases are 15 and total exhaustive cases are 36. So the probability of getting success will be 15 by 36 and that will be 5 by 12. Now we have to find average number. Here we know in case of binomial distribution, average, and that is nothing but mean, is equal to n into p, where here n is given, where n equal to 120 times, and p already we got, p equal to 5 by 12. Therefore, what is the average number of times when number of the number in the first dice exceeds the number in second dice? Therefore, expectation of x is equal to n into p. That means 120 into 5 by 12, and that is equal to 15. Okay, so this will be the average number of times when in out of 120 times where the number in the first dice exceed the number in the second dice. So another example I will do which is important in your syllabus is fitting the binomial distribution. Fit a binomial distribution. Fit a binomial distribution fit a binomial distribution for the following data. For the following data. Okay. What are the data given? X and corresponding frequencies. X is the value of the random variable and f is the number of times it occurs. So 0 occurs 5 times, 1 occurs 18 times, 2 occurs 28 times, 3 occurs 12 times, 4 occurs 7 times, 5 occurs 6 times, 6 occurs 4 times, and so total frequency will be 80. So here, whenever you are getting such type of problem fit a binomial distribution, we will evaluate the theoretical distribution. We will evaluate the theoretical distribution applying the binomial distribution. So we will fit this data through the binomial distribution. In case of binomial distribution, we know that, so let us solve it. In binomial distribution, what we know? We know that probability of x equal to x equal to ncx p to the power x q to the power n minus x. So here this total frequency I will consider as 80. So here what are the things given? Let us see. Here x is given. X is given. What are the values of x? X are 0, 1, 2, all those things. Okay. And then n is given. What is n? N will be up to 6. N is up to 6. And capital N is also given. Capital N will be 80. So what you will do whenever you are getting question like this, you multiply this value, you multiply capital N with NPX and try to simplify it. Try to simplify it. Before that, let me find the average. So from there only I can get P and Q because P and Q are unknown. So now I will find the average frequency. For finding the average, let us find the average, and that average I will take as mean in the binomial distribution, and since I know n, I can able to calculate p. So average how can we calculate is, here you see, here x and here f into x. So x is 0, f into x is 0, 0 into 5 is 0, x is 1 and f is 18, 1 into 18 is 18. X is 2 and here f was 28, so 2 into 28 is 56, and then x is 3, this f is 12, so 3 36, and then 4 into 7 28, so this is 4, this is 28, 5 6 the 30 and 6 4 the 24, and so I can have total is 192. Total is 192. So this is the product of the thing. So average will be, average is equal to summation fx divided by summation f. So summation f is nothing but 80. This is equivalent to summation f. And summation fx is nothing but 192. So this is nothing but summation fx. Now this will be equal to 192 divided by 80. And this will be equal to 2.4. So this is the average of the given problem. But in order to fit it in a binomial distribution, this average is same. So I will consider n into p. is equal to 2.4. As n equal to 6, 6 into p equal to 2.4, and so p will be 2.4 divided by 6, that will be 0.4. Accordingly, q will be nothing but 1 minus p, that will be 0.6. That will be 0.6. Now we got p equal to 0.4 and q equal to 0.6, n equal to 6, n equal to 6, and capital N equal to 80. Now what I will do, in order to find the theoretical frequency, I will find the binomial distribution in this way. So in order to fit the data in binomial distribution, we take it as capital N into NCX p to the power x into q to the power n minus x, and n is nothing but 80 into small n is nothing but 6, x we will have different value, p is nothing but 0.4 into x, and q is nothing but 0.6 to the power 6 minus x. Okay, so we will consider this. Now one by one we will find. Suppose I will consider x equal to 0, and I will have this value. Suppose this is my what is called n into p plus q to the power n. So here I will have capital N into p plus q to the power. That means if I take x equal to 0, you see x equal to 0 means what will happen? X equal to 0 means this thing will be 80 into 6c0, 0.4 to the power 0 into 0.6 to the power 6. And so if you simplify it, you will get approximately 3.72. So that value I will put here, 3.72. Now for 1, so let me put x equal to 1. So what will happen to this expression? What will happen to this expression if x equal to 1? So it will be 80 into 6c1, 0.4 to the power 1 and 0.6 to the power 6 minus 1 is 5. So if you simplify this, you will get it approximately 14.93. Similarly, if you take x equal to 2 and if you simplify 86c2, 0.4 to the power 2 and 0.6 to the power 6 minus 2 is 4. That if you simplify it, you will get around 24.88. Similarly, x equal to 3, you will get 22.14. X equal to 4, you will get 11.06. And 5, you will get 2.95. 2.95. And 6, you will get 0.33. Okay, so these are the theoretical frequency. But after getting this decimal, you don't leave here. You have to approximate this one in such a way the sum should be 80. The sum should be 80 because total frequency is 80 in the problem here. So you have to approximate, you have to truncate these values in such a way that the sum will be 80. So because of that, I will truncate the first one, this one. You see, after decimal 7 is there more than 5. So I will add 1 with the previous digit. So it will be 4. Similarly, after decimal, I have 9, which is more than 5. So I will add 1 with the previous digit. So 14 plus 1 is 15. This is approximately 15. Similarly, this will be approximately 25. This is approximate since after decimal 1 is less than 5, so the integer value will be not changed, so I will have 22. Similarly here, after decimal 0 is there, so I will have 11 here, and here after decimal 9 is there, so I will approximate is 3, and this one after decimal 3 is there, which is less than 5, so it will be approximated to 0, and you find the sum of these values, definitely the sum will be 80. Definitely the sum will be 80. So the given frequency distribution, for the given frequency distribution, we can find the theoretical distribution in this way. So this is one of the important problem in your course.